Hi, good morning, and welcome to the ZP webinar on FoodSense. So we like to do this webinar every week, and today's the 3rd of April, 2024. It's 7:15 London time, and we generally like to go live 8 a.m., but we've gone live early. But that said, we'd like to do this webinar, as I say, at least once a week. We sometimes do twice, depending on the load of questions, but we do it as part of the sort of support of FoodSense Generation 4. So I do have FoodSense Generation 4 with me today. I realize that image is slightly small, but there will be some bigger images shortly. But it's if anyone is a FoodSense Generation 4 client, then there's personal online training. So when you get this, you do get personalized training. I realized something about the personalized training that I used to feel it was a very important part of the FoodSense, let's say, I don't want to say experience, but then I realized that actually this manual was so good that people were just opening the box and getting on with it. So and the manual is actually very thin, which also represents the simplicity of this device as well. But if you are a FoodSense Generation 4 for the measurement of ginger and the measurement of capsaicin in chilies, then personalized online training, weekly webinars. These weekly webinars, in fact, are part of support. So there's a couple of customer questions in there this week. And we also have monthly webinars as well. I think it's the 24th of April. At the end of every month, there's always a webinar as well. Questions that came in today. Detection of Shogaol in ginger and the pungency of ginger isomers. This is really a sort of academic question. So if you're not so much interested in the sort of science of ginger and the various chemicals that make up the pungency of ginger, you can skip to question number 2. Question number 2 has come in from Indonesia, and it's regarding somebody's got the same concentration but different results. This is not unexpected. It's how different the results really are. So what I mean by that is if you measure something and it's 5001 and then you measure it and it's 5002, that is actually the same number. They're really both, let's say, 5000. So, but I'll dig into that more today. They're also reporting that it tastes hotter than the meter is actually recording. These people are on FoodSense Generation 3, and I suspect that actually they probably need to dilute the sample more in order to get a more accurate result. So I think they're getting precision, they're just not getting accuracy. There's a big change with FoodSense Generation 4. FoodSense Generation 4 actually guides you to the correct dilution. They're essentially unguided, but I will cover that today. And then question number 3 is history of FoodSense. We're on FoodSense Generation 4. So just a kind of quick, 1, 2, 3, and 4, what's happened over the years. As I say, there is a webinar on the 24th of April. These are more than just webinars, I should say. They're really live demonstrations. And we just do it to demonstrate the robustness of the technology. So you can come to the live demonstration on the 24th of April. There'll be one in the morning and one in the afternoon. The one in the morning is designed to try and help our colleagues out in Australia and in Asia. And the one in the afternoon really helps our colleagues in the Americas. So we do two to try and cover the various time zones. So this one is a bit of a, I don't want to say academic question, but more of a sort of deep science question. So if you're really just interested in FoodSense for measuring chilies, you can skip to question 2 and question 3. But that said, somebody really wants to understand FoodSense and its measurement of ginger isomers, and I think also the linking of those ginger isomers to the pungency of ginger. I just want to say that obviously with FoodSense Generation 4, there's a whole series, and when I use this word isomers, these are just kind of chemicals really. So capsaicin or the capsaicinoids, you have these different structures. You have capsaicin itself, which may be, depending on the source and the treatment of that source, maybe 69% capsaicin. It may be dihydrocapsaicin. And capsaicin and dihydrocapsaicin are reputed to have the same Scoville heat unit. If they were neat, let's say, if they were pure, of 16 million Scoville heat units, whereas dihydrocapsaicin is, I think, about is much less in mass and about 9.1 million Scoville heat units. When I say reputed, because I realize that sometimes the science of this is not super deep, and what I mean by that is, like, in some branches of science, you'll find lots of papers, lots of investigations, and they may be referenced to each other, and there's actually enough evidence to say, oh yeah, okay, well this is generally what's happening. But I think with sometimes in some of these sort of more niche subjects, I think it's a little bit anecdotal. So I haven't seen the paper which says that capsaicin and dihydrocapsaicin have the same kind of organoleptic intensity of hotness, and nor dihydrocapsaicin is about 60% of them. I haven't seen those primary papers, and I don't think many people actually have, is the honest answer. I think there's a lot of anecdote going on here. But that said, these things are kind of, you can find them on wiki, etc. So there's a certain degree of understanding between the chemical structure of capsaicinoid and its potential kind of perceived hotness. Now, the reason I bring that up then is because when we look at gingerol, there are all these isomers, 6, 8, 10, Shogaol, 6, 8 of Shogaol. So there are these various, not all of these isomers, some of these are distinct chemicals, but there are these range of chemicals and isomers that kind of give you the pungency of gingerol. And we can measure the total gingerols on the FoodSense Generation 4. But what I find super interesting is that I just don't believe that anyone is, at least so far, I have not found a link between the chemical in gingerol and its relative pungency. So if we look at capsaicinoids, and then people have, at least I think done the study where they've tried to say that this molecule is more, it has a more organoleptic sensation of hotness than this molecule. But I don't feel like I can find the literature, or rather I can't find the literature that says that people have done the same work in gingerol. If we do, now this person's particular question is about Shogaol, which is a similar instructor to gingerol, but is a different chemical. But when you actually look at how much gingerol is in fresh ginger, it's about 60% of it is 50 to 60% of it is 6 gingerol. About 25% of it is 8 gingerol. About 25% of it, these are abouts, is 10 gingerol, and then you got Shogaol. So I found the question quite unusual actually, because at least we find that Shogaol is actually not super abundant relative to the other molecules in ginger. So that's why I found the chemical quite, the question quite unusual. And this is the first time I've really covered the question, because actually it's a kind of a minority player among the molecules that otherwise give ginger its pungency taste. And then, as I say, finally, this is just to help me finally remember my conclusion, because if you asked me the same question about capsaicinoids, I think you wouldn't be asking me the question, because actually that literature is, or at least those perceptions of different molecules that contribute in general to the total hotness of chilies, they're generally kind of understood, that two of them are hot, equivalent in heat, one of them is about 60% of the heat, and the rest of them are in such low concentrations, they're kind of among the noise in terms of their contribution to heat. But I really feel like the amount of literature around ginger and the molecules of ginger is much less, in fact. So I think you're sort of, essentially you have to do the science in order to answer that question, and I don't think anyone really knows what the relative pungency or organoleptic sensation of pungency is in those molecules. Now we'll go to question number 2 here. Now question number 2 has come in from Indonesia. They're on a generation 3 product. So the question number 3 will be relevant. The question number 3 today will be relevant to these people, because they're on generation 3 in this particular client in Indonesia, and I think they would actually benefit from being on generation 4. So the questions that have come in are same concentration, different results. To taste, the chili is very hot, but the meter is reporting low. So I can answer why that's happening. So first of all, this is experience, for example. It's a particular hot sauce made with pepper X. I suppose the first thing I should say is, by the way, this pepper X, this sauce has a hotness of about 100,000 Scoville heat units. We do a 1 in 1,000 dilution with this particular chili sauce. I think it also features sometimes in our testing during our webinars as well. But We test it something like 5 times. The reason being is that we can't assume that chili sauces, chili powders are homogeneous. And by that I mean I can't expect to take the same sample, test it or take the same sample, prepare 5 samples, test those 5 samples, get the same result. I can't expect that. But even if it was the same sample, I can't always expect to get the same results. It's the same with HPLC as well. You'll always get a experimental error. But here, for example, we've recorded it at 94,000 Scoville heat units, 83,000 Scoville heat units, 101,000 Scoville heat units, 93,000 Scoville heat units, 93,000 Scoville heat units. This means that we have an average of 93,000 Scoville heat units. But to understand the precision, the spread in data, we've actually done what's called the relative standard deviation, and it's 7%. So 7%, in my little opinion, would actually be good enough to make medical diagnostics for, or rather you could do medical diagnostics based on a relative standard deviation of 7%. So 7% is more than good enough for understanding whether that accuracy or the average number here is essentially precise enough to be useful. And so I would argue, I'm not surprised, that you're getting different results. Do send me those results, because then I can do a proper analysis on it. We're not bad at, I wouldn't call this data analysis, it's a bit too fancy for it, but we're not bad at simple statistics at ZP, and I suppose that's part of our customer support. So first of all, I'm just giving you a reflection that, in fact, you can have the same source. I can record it 5 times. And we do this because with HPLC, high performance liquid chromatography, people tend to do one sample and assume that it's just, oh, well, that must be it then. It's like, no, actually, you have to do several samples. The reason people don't do several samples with HPLC is it's basically too expensive. It takes too long, but we can knock out 5 samples like that quite quickly. Your second part of your question, and in fact, this appears on, there's a particular link here. You can watch the entire video about that here as well. The gentleman here is a guy called Ed Scoville. He's the Guinness Book of World Record holder for the hottest chili in the world. And he has a video on his channel featuring FoodSense Generation 4. Something else that they have now is that they're they're reporting that the product is hotter than the meter is telling them. Now, again, at ZP, we are super scientific, so, we need numbers in order to really assess that. But that said, if they've got FoodSense Generation 3, they can take the hot sauce like this. They could do what we call a 1+4 dilution. And it'll probably give them a result of 5,000 Scoville heat units. And they can do that several times. The problem with it is, it's wrong. FoodSense Generation 3 doesn't guide you the same way that FoodSense Generation 4 does. So capsaicin is not terribly soluble. So when you've got hotter products, and this one will guide you, by the way, when you've got hotter products, because capsaicin is not terribly soluble, you have to increase the diluent or the dilution in order to cope with the fact that capsaicin is not terribly soluble. I super suspect that these people are under diluting, and therefore they get a precise result, but they don't realize that the solution is saturated with capsaicin. There's still more capsaicin to dissolve, but they don't know it because they're on FoodSense Generation 3, which doesn't have the kind of guided dilution. As I say, we can get a precise result if we just did a 1+4 dilution of experience, but it'd be wrong. We would be underreporting it. We actually end up doing a 1 in 1,000 dilution. You'll see this in my slides in a minute. The nice thing about FoodSense Generation 4 is it doesn't leave dilution to be kind of slightly arbitrary. And what I mean by that is with FoodSense Generation 3, you can do a 1 in 4 dilution, a 1 in 5 dilution, a 1 in 6. It's a little bit, there's too much leeway there. So we've simplified the experience, which I suppose reflects the fact that the book is so much thinner now. We've simplified the experience. It offers you 1 in 10 dilution, 1 in 100 dilution, 1 in 1,000 dilution, and even 1 in 10,000 dilution. The 1 in 10,000 dilution is because there are people out there testing things like Carolina Reaper, which are above 1 million, between 1 and 2 million Scoville heat units on those powders. So if these people were on FoodSense Generation 4, what would happen is the meter would actually tell them that they were too concentrated, Or if they were too diluted, it would tell them they were too diluted. So it looks at the data and it actually tells them that they are essentially, So if we were doing the experience and we did 1 in 10 dilution, for example, it would say too concentrated, and you could then do another dilution. You'll see some data about how it's doing that in a minute. But the thing about FoodSense Generation 4 is you've got this sensor, you've got this meter, you've got this app, you've got this cloud database, which is a big difference from FoodSense Generation 3. FoodSense Generation 3 does not save all of the data automatically to the cloud behind a username and password that belongs to you, so I cannot see your data. But what it means is if you want to share your data with us, we can. So that's a big difference, because FoodSense Generation 4 will actually give you a result on your smartphone there and then, Scoville heat units, and you're kind of happy. But actually, it also saves the data to the cloud. So when I'm trying to troubleshoot people, it's much easier because, in fact, all the data is automatically saved to the cloud. And then people can choose to share it with me. They don't need to send us the data. They can just invite us through the Julie database to actually look at the data. So with these people, I suspect that the reason that they're potentially saying it's hotter than the meter is giving them is because they're actually saturated. The Scoville heat unit, the capsaicin, there's probably more of it in the sample, but it's saturated the buffer, and they need to increase the amount of diluent in order to extract more of that capsaicin into that buffer. And the software will then automatically just back calculate the original concentration because it knows what dilution you actually use, so it does the maths for you. Just for your interest, I mean, we can categorize raw signal. We call, if it's too intense, if it's too dilute, or it's a little bit on the edge of being too intense. I'll show you what that looks like. So this is some data that we got Christmas time. It's basically flatlined. It's completely out of scale. And the meter was telling this person that as well, but I could actually see that it was a massive signal. It was out of scale. So it was easy to fix because you could just tell them to increase the dilution. On FoodSense Generation 4, by the way, it does tell them to do this. This one's too dilute, so somebody's over diluted the sample. I can see it's 1 in 1,000 here. They probably benefit from doing 1 in 100 dilution, but we could see that the signal was very small or not very intense, so that's easy fix. And the next one is little bit on the edge of the data. And we're not trying to make people look at raw data, by the way. You will get a result on your phone, and that's simple. It just means that if you want to lean on people who, like ourselves, that, really kind of understand this because, it's what our PhDs are in kind of thing, then actually you can lean on us and we can interpret the results. But this one it's almost too intense. So it's kind of on the edge. I called it anvil because it looked a little bit like an anvil. So we are able to look at raw signal on FoodSense Generation 4. So this happens quite a bit, that somebody will be in India, they'll be testing in their facility. They'll want us to check the results, and we can go and look at the results. So on FoodSense Generation 3, see, when you get an email that says, oh, well, the results are not repeatable, but I need to know what those numbers are, or the sample is hotter than the meter is saying, I probably need to know what you think or what the meter is actually saying. But with FoodSense Generation 3, see, it feels very manual. That, you have to kind of ask for this stuff, whereas FoodSense Generation 4, it all goes to the cloud anyway. We can even tell what dilution you used, what time you did it, what date you did it at, who did it. There's a lot of traceability in FoodSense Generation 4. So the history of FoodSense, and this is really question number 3. FoodSense originally came from a paper that was written by a gentleman called Richard Compton at the University of Oxford. Richard happens to be what they call an electrochemist. So he was measuring capsaicin using a technology that is fairly similar to what called glucose strips for measuring blood glucose for diabetics. So anyone who's testing their blood at home because they're a diabetic, the kind of technology that we're using in FoodSense is pretty similar to that. So there's an original paper by Richard, which is also, there's also a patent as well that ZP has licensed. But of course, you can imagine there's a lot of improvements between the original paper and we're at FoodSense Generation 4 today. But that's the kind of origin of it. And then we had a sort of FoodSense Generation 1 product, this kind of silver box here. In those days, we used to get lots of criticism because we just used to do a lot of testing on Tabasco sauce. That then matured into Generation 2. The thing about products is you're always learning, so, my phone is on, I think the phone I use is kind of on generation 12 these days, so you're always learning, you're always improving. So there was a sort of some incremental improvements between Gen 2 and then Gen 3, again, sort of incremental improvements. But really the big change is really when we went to Generation 4. Generation 4 sort of things that we learned that were good stayed the same, but anything that we learned that we really wanted to improve upon changed quite significantly. And it could be just small things like putting the sensor into the meter. We used to use these slots. The slots are horrible because slots mean that a little bit of liquid touches those slots and it would ingress or go into those slots. And once you've got slots going into electrical instruments, that's really a bad idea. So with a new device, there's user experience like there's no slots. There's also the ability just to sort of take the device apart and give it a clean. It's much easier to clean, especially when you're dealing with things like powders and liquids. So there were a few simple mechanical improvements on going from 1, 2, 3, but 4 is really when we made the most significant improvements. But the improvements also then came on the software, and Generation 4 was an improvement in mechanical aspects, but it was also an improvement on the cloud aspects. And we also opened up a Android version of the software as well, which really kind of helped with the adoption of the technology, because obviously nobody wants, iPhones can be expensive. They're not necessarily used in all parts. They are used a lot around the world, but use them in a sort of semi-industrial setting is not, it's cheaper to basically use Androids in a sort of semi-industrial application. So if I was to list out the improvements from going from Gen 3 to Gen 4, so as I say, the kind of Indonesian people are on Gen 3, that particular customer, though the distributor in Indonesia, I'm pretty sure, has a Gen 4 product, or at least is getting one. So Gen 3 had this slot. The slot is not good from a user experience. It can lead to what we call ingression of liquid, so no more slots. Important one, no guidance on dilution. When it came to Gen 3, there's no guidance on dilution, so I suspect that that's a problem that they're suffering in Indonesia. But on Gen 4, there's fixed dilution, so it's easier to actually not wonder what dilution to use. You can do 10, 100, 1000, 10,000, and there's no intelligence on dilution. So if you're too high or too low, the Gen 4 product will tell you, whereas Gen 3 definitely didn't tell you. Gen 3 was only Apple phones or Apple smart devices, whereas we've now added Android when it goes to Gen 4. This is, I think, one of the most significant improvements. There's no cloud capability on Gen 3. So essentially you get the data on your phone, but you sort of write it down and that's it. Whereas Gen 4 is constantly saving the data to the cloud, which then means that we've got traceability in terms of who did the work and when did they do the work. And we've also got, we can also support much easier as well. So much happier with Gen 4. And as I say, no data is saved and all data is saved when it comes to Gen 4. So if I looked at the question, so how much Shogaol actually contributes to the pungency of ginger products? I don't feel like there is actually that much literature out there on that. There's much more literature on capsaicins. It even appears on Wikipedia. There's not a great depth even on capsaicins actually of that literature. It's not, in some fields of science like medicine, you can have quite a, whole journals dedicated to it, and lots of journals all talking about the same kind of thing. And, there's a lot of discussion going on in the academic literature. It's just not that way in chili, and it's certainly not that way in ginger. Questions from Indonesia, same concentration, different results. Send me the results, because then I can make a statistical analysis on those results. If the chili you think is much hotter than the meter is reporting, then I suspect that actually you're under diluting. You're on a Generation 3 product. I think you should, we do an upgrade program. Talk to your distributor about the upgrade program. And then the history of FoodSense Generation 4. There's incremental steps going from 1 to 2 to 3, but 4 was really sort of, paradigm is a bit of a strong word for it, but there was actually a paradigm shift, because the nice thing about ZP is we're often the biggest users of our own products. We literally went and asked ourselves, what would we do? We went and asked our scientists who do use this device quite a lot, what would you do if you wanted to improve it? And so they actually gave us really amazing feedback. Things just like it's just one button on the device. There's LEDs that tell you the status of the device at any time. It's kind of, there were definitely some nice features. If you want to see FoodSense Generation 4 in action, 24th of April, 2 webinars, one in the morning and one in the afternoon. I appreciate the only place it really doesn't work well for is actually Australia, especially Eastern Australia. It's, Western Australia, we just about may catch you, but Eastern Australia, no, it's not so good. But in Asia, it works. Most of Asia, it works quite well. So I want to say thank you very much. If you've got any questions of ZP, don't hesitate to reach out to us. Any links that I've put up today, I'll put underneath the video on YouTube afterwards. Okay, thanks very much.